Hello, my name is Kerby and I'm here today to demonstrate basically how to build a second AC circuit video.
Alright, my name is Wilesley, Jean-Baptiste. Today I'm here for the team AC demo video rubric, and I will demonstrate and explain how to set up an AC circuit.
Hi, my name is Laz, and today we're going to be demonstrating and explain how to set up an AC circuit on Multisim as well as the bench.
Hello, my name is Thomas Lutz, and today we're going to be showing you an example of the Team AC circuit demo.
Alright, so now we're going to demonstrate and explain how to set up an AC circuit. We're going to start off by grounding the circuit. Make sure we have a secure connection down there, connected down here. The circuit's going to consist of a 1K and a 2K resistor. We're going to grab our 1K resistor, put it anywhere on the breadboard. Look like that. Then we're going to grab the 2K resistor, and we're going to make sure we put one pin on the same exact row as the 1K resistor, so that will not work correctly. And then we're going to place the other side on the ground. So our resistors are now in place, so we are going to grab our function generator. This is going to be our main power source. I'm going to place it on 50 ohm output. Now we got to put some wires to connect our function generator to the power and the ground. So our function generator is now connected. Now the other thing we need is some regular probes for measurement. And this is going to go onto the programmable multimeter. This is just going to be strictly used for measuring our VRMS. And I believe our target VRMS here will be 2 volts. Next, we're going to place a ground in between the 2 resistors, simply for the purpose of measuring across the 2K resistor. Okay, lastly, I'm going to grab our oscilloscope probes. Connect one into channel 1.
I got class.
Is there a password on this?
To channel 2.
What are you going to do?
Oh, it's so that you can work on it, so you don't have to worry about like being here.
Okay.
So that because I know.
And then we want to make sure our oscilloscope probes are always set to one time, not 10. I'll be measuring. The first channel is going to be measuring the circuit as a whole. We want to connect the probe to the main power source,
I'll text you.
and then connect the ground source to the other ground source. Stays. And the other probe, we're going to be measuring across the 2K resistors. We're going to connect one end of the probe to the power source on this side and ground it on the other end of the resistor. Okay. Then we are going to power on our equipment. target range here is going to be 1,000 hertz. So we're going to set that to 1,000. That's at 1,000. And we have our sine waves here. We always want to make sure to hit auto to clear any settings. And we're going to go to measure. We're going to display all. Our target VRMS is 2 volts. In order to measure our VRMS, we're going to connect once again power. Probes connected to measure VRMS. I don't want to set this to AC. Set the range back to the left. Target range 2 volts VRMS. So we're going to adjust the amplitude on the function generator until we get our target VRMS, which is 2 volts. I basically set it up though, we're good though. Those setting up. So to start off from measure voltage peak to peak using the old school method, we're going to go to our oscilloscope. We're going to want to, since this is the old school method, we're just going to want to line it up and kind of center it there. And as we can see, our divisions are 1 volt. So we're going to start from the bottom to the top, measuring peak to peak. We're going to manually count the squares. So we have 1, 2, 3, 4, 5, and 6 squares at 1 volt. 6 times 1 equals 6 volts peak to peak. Alright, next we're going to measure VRMS. So as we previously measured voltage peak to peak, we can determine our VRMS based off the peak to peak. And how we're going to do that is voltage peak to peak is 6 volts. And we are going to divide that by 2, and we get 3 volts. And we're going to times that by 0.707. It should give us the VRMS value of 2.121. And if we look at our multimeter, it's showing 2.02 VRMS. Alright, so next I'm going to measure time and frequency on the oscilloscope. So once again, we just want to line this up. To make it easier to count. As we can see here, each block of time is equal to 200, so we're simply going to count the blocks in for the duration of 1 complete cycle, which is going to be from here to here. So we have 1, 2, 3, 4, 5 blocks. We're going to go to the calculator here. Since we have 5 blocks, 200 each, we're going to take 5 times 200, which gives us 1,000. And to calculate time, we're simply going to divide that value. So it's going to be 1 divided by that value. So we're going to say 1 divided by that, and it'll give us a time of 1,000th of a second. And to simply calculate frequency, we're just going to invert that. So we're going to take that time, 0.001. Actually, we're going to take 1 divided by that value, 0.001, and it should give us a frequency of 1,000. And if you look over here on our function generator, that's basically exactly what we have. Alright, next we're going to check the voltage peak to peak across R2. So we're going to go back to our oscilloscope. We're going to get rid of channel 1. We're going to bring up channel 2. We're going to want to line that up. Get the scale there. That'll work. So since we're looking at voltage peak to peak, we're going to position this in the center. See if we can scale up bigger. We'll line that up right there. And we're just going to simply count the squares and times it by the division value, which is 500 millivolts. So from one end we have 1, 2, 3, and 4. 4 times 500 millivolts gives us 2 volts peak to peak. Alright, now we're going to measure the VRMS based on the 2 volt value we received from the voltage peak to peak. So if it's 2 volts peak to peak, we're going to divide that by 2. And it'll give us the value of 1, and we're going to times that by 0.707. It'll give us the VRMS value of 0.707 volts. Alright, now we're going to do the time and frequency. So since we're doing that, we're just going to line this up at the end of one cycle towards the middle, make it easier to count. And as you can see, once again, we have each division calculated at 200. So we're just going to count the squares once again. And it's going to be 1, 2, 3, 4, 5. So we have 5 squares. 5 times 200. I'll go ahead and do it on the calculator. So we have 5 times 200 equals 1,000. So if we take 1,000 and divide it by 1, should give us the time. Or actually, it's 1 divided by 1,000. It'll give us the time of 1,000th of a second once again. And then to calculate the frequency, we're just going to do the same thing with the time. Take 1 divided by 0.001, and it's going to give us the value of 1,000 hertz, which is exactly what we have in the function generator. So now that we've showed you the old school method, we're going to go ahead and do the new school method. We're going to start off by measuring the voltage peak to peak across our whole circuit. And to do that, we're just going to hit measure over here, go to voltage. Scroll down to voltage peak to peak, check that out, and it'll give us 5.92 volts. Which is our voltage peak to peak, and what we got doing the old school method was 6 volts, which is fairly close. Next up is going to be the VRMS. We're going to do the same thing over here. We're going to go to voltage on channel 1, go to, scroll down, should be somewhere right there, VRMS, and gave us a VRMS of 2 volts, which is exactly what we got using the old school method. And then we're going to measure time. So we're just going to go ahead and time. And what we want now, since it is time, we are looking for the period. And the period, turn the display or turn the measurement off. Period of time is a little bit over 1,000th of a second, but it's fairly close to what we got doing the old school method. And then for the frequency, we're basically going to do the same thing. Go to measure. Go back to time, except this time we're just going to simply click on frequency, and it's going to show us the frequency of 1,000 hertz, or 1 kilohertz, which once again is exactly what we have in a function generator. Okay. Now we're going to do the same thing across R2. We're going to measure the voltage peak to peak, so we want to make sure we're on channel 2, hit measure. We are going to go to, let's hit measure one more time, and go to voltage peak to peak, and it gives us voltage peak to peak to 1.94. Using the old school method, we had 2 volts, so it's fairly close. Next up is going to be the VRMS. We're just going to go right back to voltage. We're going to go down here to VRMS, hit that, and it's going to show us a VRMS of 6.78 millivolts. And what we got using the old school method was 0.7. Now we're going to measure time, so we are just going to click time here, go to period, because that's exactly what we want, is period of time, turn off measure so we can period, and we get 1,000th of a second, millisecond, which is exactly what we got using the old school method. And then we're going to measure frequency, so we're going to go right back to time, scroll down to frequency, it's going to show us 1 1,000 hertz or 1K hertz, which again is what we got using the old school method. And that's basically how you use the oscilloscope and the bench to create a circuit.
Alright, I'm back again, and I told you guys I was gonna demonstrate and explain how to set up an AC circuit. To start, go to Multisim, place component, sources, AC power, and drag it. And then we're gonna need a resistor, 1K. Go to basic and resistor. I need 1K. Top, and I need 2K. Okay. And then also we're gonna flip it 90 degrees. Alright. And we're gonna change, instead of using the 120 VRMS, we're gonna change it to 2. And we're gonna use 1,000 hertz. And we also need a ground for AC ground. First component, source, and use the ground first. And close. You just make it look pretty much clean and stuff, the way you want it to be. And then we connect our power source. So we change the color just to recognize the two.
I'm going to be showing you how to measure across the voltage system, illustrating how to measure voltage in peak to peak on Multisim. So the first thing you're going to want to do is take your triggers and set Y value to max. Y value min, and then that illustrates peak to peak here is showing that right here it's 5.65 voltage peak to peak on channel 1. So then to measure the voltage VRMS, you'll need to take the voltage peak to peak, which is 5.656. Divide that by 2, then take that value and times it by 0.707, which gives you about 2 volts of VRMS, which is what we had it set to.
Yeah.
So then we need to measure the time, and to measure the total time, you can also use the triggers to set Y value zero, and then go to the next one, set that one to Y value 0. And then measure the full wave pattern, which is from here, which is 1, 2, 3, 4, 5 squares at 2,000 microseconds per division, which gives us a total time of 1 millisecond, which is 1,000th of a second. And then in order to calculate the frequency, you would take your time, which is 1,000, that by 1, which gives you 1 to the power of 3, which is 1,000, which is 1,000 kilohertz. I'm sorry, 1,000 hertz, which is what we have it set to.